So in this tutorial, we're going to be having a look at the different ways you can add forces to rigid bodies using code. We'll also have a look at how you can add forces within a given region using area nodes. Sounds good? Then let's get rolling. Here I have a couple of static bodies and a rigid body for the ball. Let's have a look at its properties. Gravity is the only force that's applied to the rigid body by default, but there's also the linear velocity. Let's set the x velocity to 1000. And if we run this, you will see that it will start with an impulse to the right. And in the same section, we have damping. This is how fast the object slows down. We set this to a higher value, you'll see that it slows down a lot faster. If you set this value to -1, it will resort to the default setting. The default for this can be found under Project Settings, Physics, 2D, and then the default linear damp. So this is how you set the starting velocity of the rigid body. Let's reset these values and let's have a look at the angular velocity. Similar to the linear velocity, this is the angular impulse the object starts with. So let's set this to 40, and if we start the game, you will see that it starts with a rotating force and then slows down again. And here, the damping means how quickly the object will slow down with rotating. Now let's reset that and let's go into the last section, which is applied forces. These are forces that will be continuously applied to the rigid body. The force is similar to the linear velocity. So let's set this to 1000 again. And if we run this, you'll see that it keeps being pushed to the right. And let's reset that. The torque is similar to the angular velocity, but for some reason we have to set this to a really high number. I'm not sure why. If you understand the physics behind this, please leave a comment, because I would love to know. If we run this, you'll see that it will keep spinning. But to make the motion clearer, let's set it to an even higher number. Let's add another 0. And here you'll see that it will spin faster and it will keep spinning forever. One thing you should really avoid is setting these values directly. This also goes for setting the position. This is because your code and the physics engine won't be in sync, and this can create some unexpected behavior on the rigid body. You can set these values safely in the integrate forces method. I'll have a link in the description to a video by KidsCanCode that goes more in depth on why and how. But in this video, I want to talk about the 6 functions a rigid body gives us to manipulate its forces. For continuous forces, we have the force functions, which are add central force, add force, and add torque. And for applying impulses, we have apply central impulse, apply impulse, and apply torque impulse. Let's start with apply central impulse. For this, let's attach a script to the rigid body, and in there, let's add the process function. And in the process function, let's add an if statement, checking for if the UI accept action is pressed. This is either the spacebar or the enter key. And then in there, let's add the apply central impulse function. As you can see, this takes a vector 2. The vector 2 will decide its direction, and the length of the vector will decide its strength. So similar to what we've done before, let's set the x value to 1000 and the y value to 0. Now you can press the spacebar to push it to the right. To make this motion a little bit more pronounced, let's change the x value to 7000 and the y value to minus 3000. The y is a negative number because we want it to go up. And now it goes up and to the right when you press the spacebar. So with this out of the way, let's move on to the next function, which is apply impulse. As you can see, this function takes two vector 2's, an offset and an impulse. So the impulse is the force itself, and you could use the offset to offset the position where the impulse is applied. An example of this would be hitting a billiard ball on its side, so it starts spinning more. Now let's set the offset to be more on top of the rigid body, like the example I just showed. And then for the impulse force, let's set it to 5000 on the x and 0 on the y. If we run this, you will see that it gets more pushed forward and starts rotating more. You'll also see that the offset point doesn't rotate with the object itself. So the last impulse function is apply torque impulse. This function takes a float for the torque, and torque needs to be a really high number. So let's set this to 800,000. If we run this, you will see that if you press the spacebar, it starts spinning like crazy. I really like how this looks. So in 3D, it's pretty much the same. The only difference being that it takes a vector 3 as an input. Also note that these values are lower because in 3D, you use units to measure distance and not pixels. The apply torque impulse function also takes a vector 3 instead of a float. This right here means that we will give a torque impulse of minus 400 on the x-axis, which looks like this. The value needs to be a lot slower than in 2D, and it also seems to depend on the weight of your rigid body. Now that we've covered all the impulse functions, let's move on to the force functions, which are for adding continuous forces. Let's start with add central force. So in our 2D rigid body, let's add the ready function. And in there, let's add the add central force function. And as you probably expected, it takes a vector 2. And similar to what we've done before, let's set the x value to 10,000 and the y value to 0. Now you'll see that it will keep being pushed to the right forever. So how do you cancel out this force? You can cancel out the force by creating a force of equal strength going into the opposite direction. To test this, let's add the process function and the input check again. And then let's add the add central force function again. But then let's have it go into the opposite direction. You'll see that the force gets cancelled out when we press the spacebar. And if we press again, then goodbye rigid body. So next up is the add force function. This one works basically the same as the apply impulse function, except this one is a continuous force, so it will go on indefinitely. So let's just fill in the same values as we did on the apply impulse function. And when we run this, you'll see that it will keep applying a force to the top of the ball. Yep, next function. The next and the last function is add torque, which does what you would expect. It adds a constant rotational force. Let's again set this to 800,000. And when we run this, that's what you would expect. A constant rotational force, and it will keep going forever. So you'd think that the add force functions would work exactly the same in 3D, the only difference being that they use a vector 3. When we run this, you'll see that it doesn't. It bounces and then slowly comes to a stop. This is because the add force functions currently do not work correctly. Currently, the add force functions function exactly the same as their apply impulse equivalents. Don't worry, there is still a way to add a continuous force to a 3D rigid body. To do this, let's add the physics process. And in there, let's add the apply central impulse function. And in the function, let's put the vector 3 with the force and direction that we want it to go. And then we need to multiply the vector with delta. This is to keep the distance it travels per physics frame consistent. Et voila! It now has a continuous force that pushes it into the wall. We've covered all of the functions. Nice! So now let's have a look at what we can do with area nodes. I've re-added the code from earlier that lets you apply an impulse on a button press. Let's go into the scene and let's add an area 2D node. This area also needs a collision shape. Let's set it to auto-select the parent, so we can easily move it without selecting the collision shape. And let's move it over here. Let's also do the same for the rigid body. Let's have a look at the properties of the area node. Here you'll see that it has space override option, which is set to disabled, but it also has combine, combine replace, replace, and replace combine, which can be quite confusing when there is no explanation. For this explanation, let's keep this property in mind, the priority. And also notice that it has its own gravity factor, so the gravity direction, and its own linear damp. Let's hop over to the documentation. So disabled just means that it's disabled and it doesn't do anything. Combine means that it will combine the gravity and damping of the rigid body with the gravity and damping set on the area 2Ds that it's currently colliding with, and it will do this in the order of priority. Combine replace means that it will add the gravity and damping of the rigid body to the area 2D that has the highest priority number, and will basically replace all the area 2Ds that have a lower priority number. Replace will just forcefully replace the gravity and damping of the rigid body. And replace combine means that it will replace the gravity and damping calculated so far, but it will keep calculating the rest of the areas. I don't quite understand this last one, but let's just move on. Let's set the space override to combine. The next two variables are for setting the gravity to a specific point in space. Let's ignore those two for now, we'll come back to that later. Let's change the gravity. So we're not technically adding a force to the rigid body, we're changing the gravity. But since we've set it to combine, it will combine the gravity of the rigid body with the gravity of the area node. So now let's set the gravity factor on the y to -1. We run this. You'll see that it will float a bit because it combines the gravity of the rigid body with the gravity set on the area 2D. Right now we can't see the area, so what we can do is go into debug and then we can turn on visible collision shapes. We run it, you'll see all the collision shapes and where the area is. If you want to visualize the area without having visible collision shapes turned on, you can either add a sprite, or what I like to do is just simply add a polygon 2D. We add this and then use the first tool to add points. Let's just click on all the corners to create a shape. Let's close it up and then let's set its color to blue. And whoops, we can set the alpha to be a little bit transparent so we can see behind it. There we go, you can now see it. There are some other things we can set on the area 2D node. For example, the gravity strength. if we turn this up, you'll see that it will get pushed up more. We can also change the linear damp, which, if you remember, is how fast the rigid body slows down. Let's also reset the gravity strength. As you can see, if we set it to a really high value, then you can see that it slows down really fast. And lastly, we can also set the angular damping, which makes the rotation slow down really fast. In this scene, I've given the area a round collision shape, and I've turned on gravity point. The tooltip tells us that if it's enabled, the gravity is calculated from a point set via gravity vec. So I've set my gravity vector to 0, 0 for it to be in the center. For point gravity, there's also the gravity distance scale, which says that the greater the value, the faster gravity decreases with distance. So I've set this to 0 right now, so that when the rigid body touches the area, it will immediately get pulled towards the center of the area. And that will look like this. The rigid body is still affected by gravity, and will also be pulled towards the center of the area once it touches the collider. And as you can see, when it touches it, it will get pulled towards the center. So going back to the gravity distance scale, let's increase it a tiny bit. And if we run it, you can see that it already falls off too quickly. This is because I made my rigid bodies too heavy. So let's increase the strength of the gravity and let's test it again. You'll see that it won't be affected when it's too far from the center, but when it bounces closer to the center, you'll see that it will be affected. In 3D, they're just completely the same, the only difference being that they use a vector 3 for the gravity vector. And here, to visualize the area, I've just used a mesh instance with a custom material. Goodbye. So you can use areas with an upwards gravity vector and damping to create something like this. Or you could use it to create something like those booster things at Happy Wheels. So that was about it. If you have any questions or suggestions on topics you want me to cover, be sure to leave a comment. I hope you have a great day, and I will see you later. Goodbye.